Angle subtraction formula derivation. To derive the formula for angle subtraction, we're going to set up an XY axis and 2 points on that XY axis. In red, I have my first point with a radial length of 1 and an angle beta to the x-axis, and I'll call the point x1, y1. In green, I again have a radial length of 1. The angle alpha measured from the positive x-axis comes out, and the point there is x sub 2, y sub 2. The line between those 2 points, I'll have the line C. I can find the length of that line C 2 different ways. The first way I'm going to find it is using the distance formula. Distance formula is just a form of the Pythagorean theorem. So I can say C squared is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. By law of cosines, I can find the length of C. The law of cosines formula is C squared equals a squared plus b squared minus 2ab times cosine C. Since both equations equal C squared, they have to equal each other. I set the equations equal, and then I again use some properties from trigonometry. First, I'm going to set A equal to 1 and B equal to 1 from the triangle to the left, and I can take my law of cosine formula and make it 1 squared plus 1 squared minus 2 times 1 times 1 times the cosine of alpha minus beta, which is the same as angle C. Next thing I'm going to do is drop some perpendiculars from each of the points to the x-axis. In this way, I can use my trigonometry to say sine of beta is equal to y over 1. Cosine of beta is equal to x sub 1 over 1. Sine of alpha is equal to y sub 2 over 1. And the cosine of alpha is equal to x sub 2 over 1. I can take those values and substitute it into my equation. So 1 squared plus 1 squared is 2, minus 2 cosine alpha minus beta equals. I replace x sub 2 with cosine alpha, x sub 1 with cosine beta, and similarly I replace y sub 2 with sine alpha, y sub 1 with sine beta. Square the quantities, and just go through a little bit of algebra. I'm going to square both sets of parentheses and get cosine squared alpha minus 2 cosine alpha cosine beta plus cosine squared beta. I square the second parentheses to get sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. And then I'm going to do some rearranging of terms so I can get sine squared alpha and cosine squared alpha next to each other on the right hand side of the equal symbol. Similarly, I'm going to group sine squared beta and cosine squared beta next to each other, and then have the negative 2 sine alpha sine beta and the negative 2 cosine alpha cosine beta at the end of the equation. I know if I group sine squared plus cosine squared of alpha, they would turn into 1. Same thing with sine squared of beta plus cosine squared of beta. I can replace it with 1, which simplifies my equation. I can then take the 2 on the left-hand side of the equation, the 1 plus 1 or 2 on the right-hand side of the equation, and subtract them from each other, getting negative 2 cosine alpha minus beta equals, rearranging terms, negative 2 cosine alpha cosine beta minus 2 sine alpha sine beta. I divide everything by negative 2, and I get my angle subtraction formula for trigonometry.